Okay, there are equations that sometimes they ask about, like, boating upriver and downriver, and so you're going against a current, or the current's helping you, or maybe it's in an airplane and you're having to fly against the wind, or the wind is helping you move along, that kind of thing. Well, they're basically using the distance formula. The distance is equal to rate times time, or speed times time is what that is. But because we have a current or a wind or something that's affecting that speed, we're going to rewrite this. The speed part of it is going to show the effect of the current or the wind. And so over here we have, if the wind is helping the speed, like it's pushing them from behind to make them go faster, then we're going to do distance is equal to the speed times time, just like before. But we're going to, in this case, since we're doing water, it's going to be the current, or if it was wind speed or something, we would put that there. If you're flying against it or rowing against it, it slows your speed down. So if you're going one speed, but you're pushing against the water or the wind, it's going to reduce your speed. So these are the two equations that we're going to use for the information. So now what we know is that they were traveling on river for 2 hours. It took them to get there. They were going against a current of 7 kilometers per hour. On their return trip, they had 9 hours, the same distance. Okay, because they're going there and back. So we now have our time and we have our current information. So we're going to put in the R, and the current they said was 7. And for the other one, we'll do the same thing, but it's going to be R minus the current, because the current's going to slow down. And then the time, remember, if you're going faster, your time is going to be smaller. It's going to take less time. So we had the choice of 2 hours and 9 hours. So the T is going to be 2 here because it's faster. So your smaller number goes with your addition problem. And the 9 goes down here with the one that slowed them down. And now it says to solve for R. Well, we can use systems of equations to do this, any of those styles, but this particular one, since they're both equal to D, it's kind of like, as an example up here, if we said D is equal to 4 plus 1, and then D is equal to 3 plus 2, well, if 4 plus 1 equals D and 3 plus 2 equals D, then these two must be equal to each other. So we could get rid of this part and say, oh, 4 plus 1 is equal to 3 plus 2, and solve it from there. So we're going to do that here. We're going to get rid of the D's, and we're just going to write these equal to each other since they both were equal to D. So I'm going to put R plus 7 times 2 is equal to 9 times R minus 7. And then we just solve it from here. Your normal solving of equations from here, and work towards getting R alone.